Okay, class, we're getting this started again with a totally new section for Math 1100, still in Chapter 4. In Section 4.5, we're going to talk about exponential growth and decay. The formula that's presented here is the formula that is used for the exponential growth and decay models. It's important to pay attention to the fact that this is used for both of them, as the title says, for growth and decay models. It's a matter of reading the problem, understanding what it's asking for, and using the numbers appropriately. If we look at this first example here, the exponential equation a equals 108.3 e raised to the 0.012t describes a population of a particular country in millions, which is emphasized by t, years after 2003. When will the population of the country be 150 millions? Now that we know the formula, we're going to use that, and it's asking us when will the population be 150 million. So we know that 150 million is our A in the formula. Plug everything in, and we're trying to solve for t. So that's why the objective is to get t all by itself. And the only way we're going to do that is by utilizing those natural log functions that we had done before, and that we move things around accordingly. So, using the natural log formula, still looking at what's on the right here, if we go down to step number 4, where we have the natural log of 150 over 108.3 is equal to the 0.012t. If you go back to the last lecture, section 4.4, you get a better understanding of how we were able to do that. Then once we do that, that's when we start moving things around, and our answer is 2030. So this is example 2, which is the last example, and it speaks to an artifact originally had 20 grams of carbon-14 present. The decay model, and it gives us the formula for that, describes the amount of carbon-14 present after t years. How many grams of carbon-14 will be present in 8,243 years? Round your answer to 2 decimal places. As I said before, this can be used for growth or decay. This time it's used for decay. Now let's look at how this was set up. We have to substitute t equals 8,243 in the model that is given to us. Once we do that, the first thing is to multiply those exponents together. And you see we have the negative 0.997403. Then you raise that e to that power in your calculator, and then you multiply that by 20, and you get 7.38 grams. A rule of thumb that I mentioned during my last lecture: when you're placing this inside your calculator, it is in your best interest to take the 8243 and multiply it by the negative 0.00012 first. Once you get that answer and raise it to the e power, raise e to that power, then multiply that by 20. If you do it all in one step, there's a possibility you're going to get the incorrect answer.